All right, welcome back. So, Heart Academy, January 25th, 2017, and work for 8th grades on practice of formula for rectangular prism and cylinders. First video contained 3 samples of a cylinder, and this video will contain examples of how to use the rectangular prism formula to solve these problems. Okay, this was from last night's homework, so I'm going to do 3 of these, and maybe 4, depending on how much time I have on a video. All right, so the surface area equals 2 times width times length, plus height times length, plus height times width. Okay, so we're going to go ahead and start filling it in numbers. Oh, yes, but I remember now some people were always asking me, hey, Miss Hart, how do you know the difference between the height, the length, and the width? And so I tried to explain to them what I see in my head, and it just completely made me sound crazy, but I went there anyway, just to try to explain flat bob cube pants.
It's cube bob flathead.
If you had seen the first video on surface areas of cylinders, you will know that was the voice of my brain. So when I get something wrong, or if I'm too slow with something, the voice of my brain will actually, become audible for everyone to hear. I don't know about you, but the voice of my brain sounds like an adolescent boy in 8th grade. Here we go. And that tone, oh yes, I love that sarcasm tone. It's got to be a great thing. Here it is, okay?
Are you trying to be passive-aggressive with me?
Did you see that? What you trying to say? No, Brian, you know I love you. Okay? I meant, like, look at where I am today because of my brain. Ah. So, here it is. The less you want to do is mess with your brain. Oh, that was a good one. You got to bet. Okay. Anyway, flat bob square bowling pants. Wait, what do we call this again, brain?
Oh my god. It's cube bob flathead.
Okay, cube bob flathead is relative to SpongeBob SquarePants, and this is what I mean. You can take any rectangular prism, because it's 3-dimensional, and start picturing it as an animated object. So I would put my eyes here, and here's his smile, and he would have an arm coming out, right, and some feet. Okay, there he is. That's the cousin of SpongeBob SquarePants. And then, for some reason, they have eyelashes. Okay. Yeah, well,
I don't know if the eyelashes is what worries me. More of the giant tumor coming out of his back.
Right? So anyway, if you're looking at it this way, now imagine, this relative of SpongeBob SquarePants with clothes on. So, what we're going to do is figure out where would his belt be. His belt would be here, or any direction that's going this way, which this one would be parallel to it, so it matches. So the width, because the width is belt, the belt girth, and so width is going to be 10, and then you would figure out how tall he is. This one tells you how tall, so that would be height, and then if the sun was shining bright, this is how you have to look at it. Where would the shadow be? The shadow would be laying this way. So that tells you the length. Okay? So height, width, length. If you have an idea of looking at it this way, you can always tell what block represents, or what number on the block represents the 3 dimensions. For example, this one. Now, think square bob, cube pants.
Cube bob flathead.
Cube bob flathead. Thank you, Brandon. And for the next one, and see if you can come up and figure out where the dimensions would be. So if I'm looking at him this way, I would draw his eyes, arms, legs, and now I can see where the dimensions are. So for this one, here's your width, belt, height, how tall. If the sun was shining, this would be your shadow. So length. All right.
And that's unfortunate for him, because everywhere he looks, the sun is always in his face.
Brian, that's a good point. Huh. Didn't think about it that way. So if you're more sympathetic to this animated creature, if you look at the sheet that I provided for you Today in class, if you weren't here today in class, you can get this.
My lab.
Yeah, on my lab, which I will place up there shortly. You have a little cheat sheet in which it tells you the same thing, just not in a charismatic, understanding, cartooning way of the dimensions. Length, width, height. You could use that, but yeah. Thought mine was a little bit more creative. Good. So anyway, going back to solving the first problem. Now that we know what everything is, I can now plug them in. So I have two. That sounded like when I first thought Katrina had to do numbers. 1, 2, 2, 3, 4. No, girl. Anyway, I digress. 2. That's that one. Length. Width times length. Thank you, Brady. Width, 10 times length, which is 31. I'm going to add that with height, which is 25, times length, which is 31, plus height, which is 25, times width, which is 10, and so what we do now is multiply the three sets that we have, which is this, this, and this. Okay, so I have 10 times 31, which is, that should be 310, right?
What is?
10 times 31.
310.
Woohoo! Only knew that because it's multiplied by 10. So, y'all heard that confirmation though from my brain, right? All right. Add
Yeah,
that
the one in the
with
room is just Alice. She's like not agreeing with
25.
It's Alice.
25 times 31. Alice is like, what is going on?
Why are you flashing the letter?
775. Oh, right. Add that to the 25 times 10.
250.
Thank you. 250. And, okay, so now we add all three of these together.
Come on, I can do it first.
Okay, I'm just gonna do two more problems, Allison. Okay, so
1,335.
you see how fast the brain works? Alrighty, 1,000. I already forgot, brain.
335.
And then we were measuring in meters, so we'll do meters squared. Final answer for this one is 1,335 meters squared. Okay, so now let's take a look and see what we can plug in for number 2. Poor Alice. Confuse that girl. All right, number 2. I have 2. The width is 29 times the length, which is 35. Right? So remember, width, that one's length, this one is height. Okay. Plus height times length and height, 21, times width, which is 29. Okay.
29 times 35 is 1,015.
There. See that? 1,015. Thank you. And then 21 times 35. Wait, did I do that right? 29 times 35 is this?
Yes.
21 times 35?
735.
735. Look at that. Go brain. And then 21 times 29.
I'm just gonna let you do this one.
Oh, God. Okay, so my brain just let me go. All right. So I'll use calculator. 29 times 21. 42. Is that right? All right. So 42. And we're going to add all of these together. Okay, that
Do
looks
you
like an H.
seriously think it's 42?
Did I do that wrong?
It's
Oh, I'm sorry, Brain.
109.
See how great my brain is? He caught me on that mistake. Okay, so, see?
I mean, if it was addition, maybe. But even then, that would be 50.
So, you know, and this is, children, the reason why you need to treat your brain with kindness so that you don't make mistakes that like that. And your brain will catch those things for you because that's what it does.
Don't anger the mighty brains.
What, right? 105? I know what y'all are thinking. You wish your brain could talk too. Like out loud where everybody can hear it. And not
That's
just
a
in your head by
sassy
yourself.
and beautiful, deep, dark voice.
You know, you wish that your brain could speak what you're thinking about.
Yeah. That was the subconscious, who's always double checking to see if what we're doing is, ethical. All right. So adding these together is 1,449, but we can't forget to do one last thing. Because remember, we still can't forget that 2 that's on the outside. And that means to multiply. Okay.
2,898.
See how fast I was? 2,898 is the answer for this. And it shall be
Inches squared.
inches. Look at that. Inches squared for number 2. So it is like a lot of work, but not too complicated. It's just a lot of things put together. But doesn't this make you feel smart being able to evaluate this equation, this formula? I say you should be like practicing this over dinner to see if your parents can do it. Yeah. And and that way, charge money. Say, hey, I bet you I can solve this. Right? And get some money out of that. And if you children do, remember you owe me 50%. So, I'm going to do one more. Surface area of this one. So I have 2 times, okay, this is the width, that's the height, think shadow, this is the length. And, hey, but you know what? Ooh, brain, guess what I just saw? Oh, you're going to be proud of me, brain. I just figured something out.
I don't know if I would be.
Okay.
I'm scared right now.
Right? So if we do this, right, we can see what our dimensions are, right? And so that would be
Who cut off
the,
his leg?
okay, don't make fun of the handicap. And now that would be width, height, length, right? So width, height, length. However, what if someone saw in their head brain, what if their brain told them to draw like the other way? Do you see the other way? Or is it just me?
You mean the eyes facing in a different direction?
Yeah.
That's not too hard to imagine.
Okay. I'm glad it wasn't just me. Like this way. That changes things. That's width. That's length. That's still height. Right?
Yeah, you see,
I get it. Oh.
the thing is, it's that the one thing that's always confused me about math, me, the magical brain, I know it's shocking to you, the audience, but I mean, if you look at the box from a different direction, like if you were to place a physical box down and have the class do it, if the dimensions were all different, each person would be looking at a different width. So,
Very true. So, but I'm thinking that no matter how you look at it, right, we're still just multiplying each one with everything.
yeah, it's multiplication, so it doesn't matter what order you place them in.
That's why it's the brain. See that? So, it really doesn't matter. Because of the multiplication, you should still come up with the same answer. Very nice. All right, let's plug in this formula. So now I have, my subconscious is done with this homework, 2 times, okay, the width, I'm going to look at it as 19, times the height, which is 39, plus height 39, times the length, 28, and plus the height, 39, times the width, which is 19. This video is about